Good afternoon, everyone. My name is Thomas. So today the topic is Advanced Assembly Extension. So first thing is the topic. So today I'm going to cover this copy geometry, which is involved internal copy geom and external copy geom. So in fact, it is about two different areas. Then I quickly talk about what is the skeleton model in AAX. And also the next one is the advantage of published geometry. Then in AAX, right, we got another feature called inheritance feature when we can use it. So of course, with this additional extension, these are the area that is not included in the essential. So let's start the demo. So when we talk about advanced assembly means large assembly, and sometimes not necessarily must be large assembly. When you want to share information from one part to another, we need advanced assembly. All right, we need to share how effective you can share information from one part to another. So this is the main topic for AAX. So this example here, I got one motor, whatever name you want to name it. So the first thing I'm going to show you is the copy geometry, internal or local copy geometry. So for example, right, if I want to create a new part for this assembly, I'm going to go to create a new part. For example, I say this is a new top cover. So I'm creating a new top cover part using the template, and I located using the default constraint. All right, so I got a new part in the assembly. Now, traditionally, right, what you would do when you want to copy information from the local part. First thing, you need to activate this part. All right. Without AAX, right, you can copy any surface you want. For example, you can select the surface and then Control C, copy, and Control V, and you paste it. You can also do this without AAX, but if you have AAX, right, what you can do is you can use a copy geom. And for the first example, I'm going to show you now. I'm trying to show you in context copy geom. Last time we called a local copy geom. Okay, meaning that this copy geom, right, must be worked in the same assembly. So I'm now trying to design the top cover here, and I need the surface from this part. So I go a copy geom, and by default, right, it is in context. Now, by default, also it will turn on the published geometry, meaning that you want to the content, right? You are copy from another geometry called published geometry. So we'll talk about this published geometry later on. So now I just turn off it. When I turn off it, right, this will pop up. The references will pop up. Now, the advantage of copy geometry is you can copy surface. Any surface that highlighted here, you can select, you can click and copy, right? Once you click, it will be inside here. You can select more surfaces to copy. You can copy body from Creo 7 onwards, right? We got multi-body. So you can also copy body. You can copy change. Change means edge, right? You can have a console. You can have a combination of copy certain surface, copy certain body, copy certain edges, and references. References is referred to datum plane, datum axis, datum point, etc. So you can have a different object for you to copy or for you to include in this copy geometry. Okay, so for demo purposes, right, I don't want to make it too complicated. I just simply copy these two surface, which is highlighted over here, and simply say okay. So this copy geometry, right, it will copy into this new part, new top cover, as a local copy geometry, right? Local or in context, meaning that this copy geom must be worked in the same assembly, in the assembly level. Okay. So one more advantage is whenever, right, the designer, if you open this top cover in a separate part mode, you can see the surface that you needed for your reference. You can use this surface for your further action. For example, I want to thicken the quill here, right? Thicken with certain thickness, for example, right? like this. So you can add continue your design from this copy geometry surface. Another advantage is the parent and child relationship, the dependency. When you edit definition, the copy geometry, you can see there is an option here. It allows you to do some fine tuning. For example, this is one of the areas that I would like to highlight over here. For example, right, copy geometry update, it is always automatic update. So automatic update meaning that if the origin updated, this surface, the copy geometry surface will be updated. Then the following action, for example, thicken, will be updated. Now, if you check on this manual update, right, you can provide notification. So meaning that when the origin is updated, this copy geometry will not update immediately. It will ask for permission. So only when you say, okay, update, then the following action will be updated. If in the cases, right, you want to break the dependency, you can always check on this no dependency. Okay, once you check on the no dependency, it will ask you to break the dependency. So be careful. If you say okay, right, you cannot undo. You can undo in this section only. Once you save it, next session, right, you cannot say go back to automatic update. So no dependency is permanently delete or remove the parent and child relationship. So if you want to temporarily remove the parent and child, you can always go to manual update. So that you can whenever you neglect, right, you can always check it back to automatic. So this is one of the advantage of copy geometry. The dependency is can be played in this case. Okay, so I will take this opportunity to, for example, I use a surface to do this thicken. So I do the thicken. Then I can use the flexible modeling to maybe to select surfaces here. All these surfaces, right? All these surfaces I selected. Then I can do a further action for my design. So for example, now I selected these few surfaces and use flexible modeling to fill up the gap. So here we go. I fill out all the gap. So I design the cover. Of course, you can continue adding round, etc., for the real design. So once you've done all this, when you go back to the assembly, the new top cover, right, has been updated. And this top cover, the copy geometry is a children to this part. Okay, so this is cover the first topic, the local copy geometry, right, or internal copy geometry. Okay, we continue to talk about skeleton model. So this is assembly, and when I toggle when I turn on the cross section, you can see, right, this is a complete engine which involve mechanism. For example, I'm able to move in and out. I'm able to rotate this bar. All right, all these are driven by a mechanism. So it's a complete full assembly. So when you do a large assembly or when you do a complete assembly, right, the relationship between each part is very complicated. So how can we effectively control all the relationship from top level? So with AAX, we allow you to have a skeleton model. So the skeleton model is always located at the very top part, like this, right? Skeleton model. This skeleton model, right, will contain of you can design like curve in the skeleton model, right? To design your space claim, right? Your location of the part. You can have a coordinate system in the skeleton model. You can have a solid in the skeleton model if you want, or you can have a surface in the skeleton model. So AAX allow you to create a real skeleton model. Now, how to create a skeleton model in AAX? We just simply go to here, again, create a new part. But now, of course, it's not a new part, but it's a skeleton model. Skeleton model. So give a name of your skeleton model. You can rename it, for example. Then you hit OK. I select the template as usual. you hit OK, you notice that a skeleton will be automatically example here, and it will automatically go to the very front. See, I did not do insert mode. I'm here. I was here, and I just insert a new skeleton model. The skeleton model will automatically go into the very top part. Right, then of course you can open this skeleton model as usual, like a part mode, Then you can start design your reference, your top level references. And also, right, if you take note on the skeleton icon, it is a transparent icon. So to Creo is recognize this part as a skeleton part. For us, right, we recognize this as skeleton part by name. Because the extension for skeleton part is also .prt, it is like normal .prt. So by looking at the extension, you cannot tell whether this is a normal part or this is a skeleton part. So for us, right, usually they will have an underscore, a scan, right, to identify this is a skeleton model. But to Creo, he know this is a skeleton model. He know because it's a transparent icon. So the advantage of this using skeleton method top-down design, when you go to the drawing BOM table, you can filter out all the skeleton, meaning that you don't show the skeleton in the actual BOM table. Okay, so I will open up the original skeleton model for this example. So for this example, right, the original skeleton model contain of a few curve only. To make it simple, I've contain a few curve. Maybe the first curve, right, is for fixed motor. So this is for one engine. Another curve, right? This curve is for moving motor. Then I got the L bar. For these two holes. So all this information, right, is a top level information for those who are the project leader. He or she, right, want to plan the location of the engine, the location or the design, the shape of the model. You can do it in the skeleton part. Okay, so once you do all this information in a skeleton model, in the actual skeleton model, you may have a lot of curve like this, a lot of curve. You may have a lot of datum. You may have a lot of datum plane. Okay, you may have a lot of coordinate system, right? For engine, for automation company, right? They may have a lot of coordinate system for the location of the module. So you may have a lot of information in skeleton model. So how can we effectively inform the downstream what information you need to copy, right? So here we come to publish geometry. So usually, right, in the skeleton model, you are going to design all the top level information, a lot of references, a lot of surface, a lot of curve. So you know, right, which curve or which surface you want to share with which engineer or which model. The method to share this, right, we use publish geometry. So we come back to the skeleton model. So for example, I got a curve called L bar, which is this one. This is the one. So I want this L bar to be shared to the engineer who designed this L bar. I already roughly draw the shape out with the whole position. So the published geometry, right, will be automatically located at the very end. So when you edit definition, the published geometry, you can see what are the surfaces include in this public geom, in this feature, or what are the body, or what are the curve. In this curve, in this case, right, these three curves will be involved in this public geometry. And I got two datum axes I want to share to the downstream. All right, so I use public geometry. So the question is, where is a publish geom command? The publish geom command is under tools, publish geometry. So I just quickly do one example. Click on the public geometry. You can select any surface you want to share. You can select any body you want to share. You can select any change you want to share. For example, I want this curve to be shared to my top engine, for example, right? Then you just say OK. The public geometry will be automatically go to the footer. And then you can rename. For example, this is public geom for maybe you say top moto. Whatever name that you can plan and you can understand. So by so on and so forth, right? The engineer who designs skeleton can plan all the public geometry in this area. Then, when the engineer who really designed this L bar, he might not working in the assembly. He might work outside the assembly. For example, when he create a new part, right, outside the assembly, meaning that I close the assembly, I create a new part outside the assembly, externally. For example, I say this is new L bar, right? So I designed this new L bar, not in the assembly. This is outside the assembly. That's why I come to external copy geometry. So for the engineer who are designing not inside the main assembly, you are outside the assembly. How are you going to copy geometry from other? So we use the same copy geom. So you will notice that you are outside the assembly. So you automatically toggle to external. Then you can say open. So you want to copy from who? Okay, for this example, right, I want to copy from the skeleton. From skeleton, right, from skeleton. So then, right, he will ask you which public geometry you want to copy from. So when you click on this, right, the skeleton will show you the preview window, and you may have the model tree for the skeleton. Then you just simply go to the footer. Then you can see all the skeleton available. Then as an engineer who designed the L bar, right, then you look for the public geometry is for you. It's designed for you. Just so you just simply easily select the public geometry from the skeleton and hit OK. All right. So inside the new L bar, using external copy geom, you successfully copy the geometry that needed for this design. Right? Needed for this design. Then what you can do, you can try to use maybe a region to do the extrude, like so. Maybe make it to be symmetric depth, whatever depth that you know, right? If you're the designer, you should know what is the depth that you need to use. So very quickly, right, you get the shape done. Of course, if you want to add the detail, like for example, round, chamfer, etc., or additional hole, etc., right, just continue from here. But the important is the external copy geom, right, is come from the skeleton. Now, again, on the dependency, right, when you go to the option, there's a same dependency over here, automatic update or manual update. If you want to temporarily disconnect this new L bar with the skeleton, you can make it to manual update. Then the skeleton update, your L bar will not update until you say update. Until you hit this update, then only it will update. Okay, so this is the external copy geom example. Now, one more good thing about external copy geom is when come to a motion scenario. For example, right, this part I design externally. Once I complete this part, I can go back to the assembly, right? Go back to the assembly. I can hide the skeleton. All right. So I would like to assemble my L bar into this location. Okay. So I'm going to toggle this part. Right. This is a moving bar. Remember, this is a moving bar. This is a moving bar. So I'm going to assemble the new L bar in session because I haven't saved it. So the new L bar, right? So this L bar come in. Now you just simply assemble as usual. For example, you want this hole to this hole. Okay. Then you may want it to be symmetric to the center. or you can just use this surface to this surface, then make it to a distance. Coincident, make it to a distance. All right, then you can specify what is the distance that you needed for this case. Of course, if you got a datum plane, right, you can use the datum plane as a meter, and like this. All right. Add one more new set. It's a mechanism part, right? This, and this. Is it done? So here we go. This L bar is designed outside the assembly, but follow the information from the skeleton. So once you've done this, you are able to move this part with this L bar, right? So this is the advantage of external copy jump. So here we come to the last one, the inheritance feature. In AAX, we got one inheritance feature. I noticed a lot again, many users, they do not aware about this function. So I will use this example. Maybe I will use this bar. Okay, this bar. So this bar, right? This is a part inside in the middle of the assembly, and this part, right? I want to do some changes on this part. So I would like to open this part in a separate part mode. It's easier for me to take a view. All right, a look. So this is the imported data. It's a step file or IGS file, which I'm not able to change it. I'm not able to change it. So I would like to make it smaller a bit, like this. Then for this demo, right, the story is I got a standard design in my library. It's a standard design for this type of holder or handle. Okay, if you look at the detail, right, this is about 5 hole. For this design, right, I got about 7 hole, diameter different, shape different, right? The plate different, the plate shape different, huh? But overall, it's about the same, right? Because they are almost a standard item, no? A standard item. This one got maybe a taper. This one got no taper, right? So they are not exactly the same, huh? So this is my standard design. This is my standard design, and I want to use this standard design with all the feature that this standard design is designed in Creo. Allow me to do changes or edit. I want this information to copy, to replace this step file. How to do that? So I will use a normal cutaway, a normal extrude cut to remove the backside. All right, to remove the backside. Then I would like to copy the whole thing into here. Do you know what is the command that we use for this type of action? Usually, right, people will use merge. Yes, this is the right command. You can merge the whole entire model into here, right? Into here, like this. So when you click on this, you are doing the external merge. Now again, this one must be AAX. If it's without AAX, right, you cannot do external merge. You can only do a local merge. Okay, so external merge, it allowed me to open. Open what? Open the standard design. The standard design, for example. So the whole entire standard design, will be assembled into this part. So I'm going to use, I'm going to maybe select the cylindrical surface to this cylindrical surface. I can take a preview. Then I continue with the flat surface to mate with this flat surface. All right. So this part is going to assemble into this new part. So this is merge. Now, when you come into the model, right, without AAX, you are successfully merged the entire model into this part. Now they all become one item. We do a cross section. We quickly do a cross section. As you can see, right, it already been merged, become one solid. But then you see what's the problem? I think you can see some problem, right? Oh, because this standard item, right, the diameter slightly different compared to the part that I want now. Oh, so how to change the diameter? With the normal merge, you are not able to edit the feature from the origin. So this is where I do edit definition, of merge. This is where you need to turn on the merge inheritance. When you turn on the inheritance, click on the inheritance, that's it. After you click on the inheritance, it becomes external inheritance. You can do a merge without adding an additional body. So the new inheritance part will be merged together with this origin. This is the meaning of merge. All right, so I turn on the inheritance and I say, okay, see what's the difference. Now, from the feature, you can see inheritance. You can expand the inheritance, merge. You can see all the detail, all the feature, like in the origin. All the feature, like in the origin. See, all the feature from the origin is now available in the result part. So what is the advantage? The advantage is this standard design, right? It may use by other design as well, because other design also copy, also inherit the whole entire model to them, you know. So when you come to this design, I want to change certain diameter, for example, right? This diameter is the first feature, the revolve. I can do edit dimension in this part. For example, I look at the diameter. So I got to find out where is the diameter to drive this feature. Okay, this is the diameter. The origin is 22.5. When I double click on the 22.5, right, it will ask me, do you want to make this dimension in this part to be independent? But in this origin, right, it still remain 22.5 because this origin is still sharing by others, you know. So when I agree with okay, this 22.5 in this part can be changed. For example, I say 19.5. Why I know 19.5? Because I already checked what is the diameter. What is this diameter? I already measured just now. I forget to show you. So when I hit OK, okay, when I double click here, I say OK, and I hit 19.5, enter. So it will change to 19.5. See, change to 19.5. And once you regenerate the whole thing, 19.5. All right, this is the inheritance item. Only change this 19.5. But for the origin, right, the revolve, right, the revolve, if you check the revolve diameter, it is still 22.5. So because don't forget this design, the standard design is still sharing by others' design. So let me close it, come back to here. So this is the example of inheritance. You can have a certain feature to be independent from the origin. It allows you to do so. Okay, so if you want to know how many dimension has been independent, you can always go to vary dimension, varied dimension. It will show you a table. This is the dimension that already been, we got a new value. Of course, if you remove this dimension, then it will go back to the origin. It will go back to the origin, which is follow the origin, the master, which is bigger. So come again, go here, look for the feature that you know which one to drive the dimension. Go to the dimension, double click. He'll ask you to confirm. You say OK, and you hit it. You key in the value you want. Then you do a regenerate. You update accordingly, right? The feature is updated accordingly without affecting your origin. The origin is still sharing by others. So here we go. I got a new part. With my new design, my company standard design. So when I come back to the main assembly, right, has been already updated to this, and all the mechanism, right, all the mechanism still intact. You will not lost the mechanism. The mechanism is still intact.